Okay, welcome to our fourth lesson of the unit on mutually exclusive and non-mutually exclusive events. And so here's like a quote I took from Einstein, just to kind of think about this idea of mutually exclusive being things, being two of the same thing at one time, and it's more helpful to understand after you kind of check out the lesson. But it's what we're going to be talking about today is all about overlap, and so like right and popular is not always like you can be right but not popular, popular but not right, right and popular, and so it's just this idea of things that are non-mutually exclusive. So we'll learn what that word means. And so here's a question that you can try and think about. So probability that a given student participates in baseball or football but not soccer. So what you have to understand here is that so what you have here is a Venn diagram of all the different possibilities that you could be. And so what you have to be clear on is the numbers don't count, like you're not counted more than once. So if you're in this group of 27 students, these are football players. They don't play baseball or soccer. But these 8, 6, and 3, they are also football players, but they could play baseball or soccer. And so together, they make all the football players. There's more than 27. There's 30 plus 8 plus 6, which is 44. And so that's the number of football players. And so the probability that you're in baseball or football, but not soccer, is like the 10, 8, and the 27. So these are all the soccer players, not soccer, baseball or football. And it doesn't say baseball or just football or not both of them. So you've got these three categories. So if you add those up, divide them by all the numbers added up, that would get you your probability. So the first thing we're doing is just kind of looking at what a Venn diagram looks like. The learning goal is being able to display non-mutually exclusive events. Mutually exclusive are a lot easier, so we will be talking about mutually exclusive, but displaying them isn't as hard as displaying non-mutually exclusive. Differentiating between them, calculating probabilities, and using notation to describe different elements. So first off, some definitions. Mutually exclusive are things that cannot happen at the same time. Some examples are you can't turn right and turn left at the same time. You can't be even and odd at the same time as a number on a die. You can't win and lose a game at the same time. You can't run and walk at the same time. Non-mutually exclusive is a different story. It's things that can happen at the same time. So you can drive and listen to the radio. You don't have to listen to the radio, but you certainly can do both at the same time. You can be even and prime. The number 2 is even and prime. Losing a game and scoring. So you could lose, but you could score a touchdown or score a goal. And you can run and sweat. You don't have to sweat. You don't have to be running, but you can be doing both those at the same time. And they make probability more complex because then there's this need for a Venn diagram to look at the number of overlap. So some notation. So now we're actually talking about like two different events. And so before we only talked about A, now we have B. And so the union of those sets is called A union B or A or B. So it's when you're in either category. And so that's typically when you have to add up things. And then A intersection B, this little upside down U, is A and B. So it means you're both of those things at the same time. So football and soccer and baseball. So just a quick example, just with cards, red cards and number cards, you can see there's overlap there. You don't have to be a number. You can have a face red card. You could have a black number card. But there is overlap. And so this is what the Venn diagram looks like. If we call A red cards, B number cards, you've got in the middle here the intersection of the two. A, it's kind of misleading here. It's this whole circle, not just this part. And B is this whole circle, not just this part. But this here is called the intersection. These three numbers all together is referred to as the union. So you can see those 20 red number cards, those 20 black number cards, and those 6 6 red face cards. So the things that are outside of the number cards. You can see the 40 number cards, the 26 face cards. The 26 red cards with the half the deck. You can see the 40 number cards and the 12 face cards. So out here you've got the 6, the guys that are neither red nor numbers, so those 6 black face cards are out here. We won't see this a lot, and it's not a big deal, but it's like I just wanted to label it something, and so it's the union is all of 3 of these. This is everything outside the union, so it's that number 6. You can do this just by putting the number there. You don't actually have to label it. It is helpful to know that this is the intersection, though. Continued, what's the probability that you're a number or a red card? So number or red is all 3 of these. That's the union. It's the 3 added up. It's 46. That's the N of. And notice we don't call it N of A. We call it N of A union B. So it's like really what you want. You could call it N of A. It's just the event of winning. And then N of S is still 52. And so you got that 46 out of 52. And then you can also do it as like just to sort straight up the probability rather than doing the N and divided by the 52. You can just say, oh, it's the probability of each of these categories, 6 out of 52, 20 out of 52, and 20. Okay. This is what we call the principle of inclusion and exclusion. So it's just this idea that if you wanted to find the union, you can add A, so add the probability of A plus the probability of B, or the number of A and number of B, and then subtract the intersection. Because like if you watch my mouse, you can see like when I count A, I count that 20 and the 6. And then when I count B, I count the 20 and the 20. But because we counted the 20 twice, we actually have to subtract that off. And these are the same formula, it's just like union is or and the intersection symbol is and. Example with formula, if you wanted to do A union B, you could say probability of A, which is 26, probability of B, which is 40. Now you're up to like 66 out of 52. So you got to subtract that intersection of 20 out of 52. Okay. And the formula only works when you have 2 categories. If you had 3, like the baseball, soccer question, the baseball, soccer, football question, like it kind of gets more complicated. There is a formula, but it would just kind of avoid it. So here's a question that we can do with 3 categories. So we got people that watch the news at noon, 6, and 11. And so here's some data, like you've got the percentages here, and we're just going to really use the percentages. So what you would draw is like your 3 circles, A, B, and C, and that represents the entire circle. And then what we do is like we start to fill in the categories that we know. And so it's probably helpful if you haven't thought about this yet to just pause the video and see if you can fill in those categories with that data. The only thing that we know for sure is that 10% watch all 3. If you try to start putting the 40 down watching the news at noon, notice that you have like 1, 2, 3, 4 sections to fill in, and you don't know where to put the 40. So what we do first is like we know for a fact that 10% watch all 3, so we can put the 10% in the middle. And then if 10% watch all 3 and 20% watch 6 and 11, so if we go to 6 and 11, if this section here has to be 20% and 10 watch it all 3, then this section here has to be 10. And then kind of continuing on that way as we go up the list, that section needs to be 10, this section needs to be 15, so that the people that are noon and 6 add up to 25. Now notice when it says like 25% watch noon and 6, it doesn't say noon and 6 and not 11. It just says noon and 6. So the 11 people are included as well, the people that are watching at all 3. And then 50% watch at 11, they could watch it at noon and 6. And so if we look at the 50% for 11, we've got 3 categories here at 30. So the section that's just watches it at 11 is only 20%. And then you watch how this happens. Like you can keep kind of going with that same idea. So this adds up to 60, this adds up to 40. Then if we count all this percentage, we add up, figure out how much we have. And notice that we only have 95% that are accounted for now. And so there's going to be 5% that don't watch it at all. So watch at least one program. You could use the indirect method there, where you take away, if you're watching at least one, if you're part of that 95% group. So you could say 100 minus 5, and then watch exactly one is just this 25 and 25 together. And these are some questions that we actually in class will do together. And so it's the same idea. Question 2 is very similar to the news question. It's just kind of written a little bit differently, and there's probabilities there. As a partial solution, like I've posted this Venn diagram so you can kind of make sure that you can get those numbers and answer the questions. Number 3 is similar too, but you notice that it's only two groups, basketball and volleyball. And then number 4 is similar as well, but again, and we'll take these up in class. It's just headache, cold, and neither, and so there's only 2 groups there. Partial solutions are here on the slides, and then you could answer probabilities after with these slides 3 and 4. And then there's some homework.